that was pretty good, and I guess you had to rush to get it. So today I'm going to talk about building a high-profile editorial website and a few things that you must check on your to-do list before going live. It's before starting, who in the room is working on this kind of website, high-profile editorial site? Okay. And by high profile, is it above a million page views a day? Below a million page views a day? Above and for above 100,000 page views a day? Okay. So this is the kind of range we are going to talk about by high profile. I don't mean Google high profile or Facebook. This is a totally different story. This would be a typical newspaper in a country. And it will be from 100,000 to few million. And the caching strategy don't really change, and we will talk about it. So this talk is coming after I'm working at Lincoln Loop, and we are tackling this problem, and at many conferences we are giving a talk around this because it's what we are doing, but we are taking it from a different angle, and there is a few other talks that we get that talk about another perspective of a similar topic. The first one is about moving legacy migration, and this is something that I would never stress it again enough. It's very, very hard to move legacy migration from an old system to a new one. Like, this is taking a lot of time. The second one is about the process of building the CMS itself, that we are not going to talk in this presentation. And the last one is, when it's built, you want to optimize it and start finding the bottleneck and apply load test. And that was a talk we gave at DjangoCon US, which is still relevant. So today I'm going to start talking about this kind of website and telling you the challenges and showing you a few pictures, because we have to put pictures, is what I've been told. And then I will talk about the multi-layer cache to protect your database. It's probably the most important thing when you start to work at scale is you need to have a cache strategy. And you want to protect the most precious asset in your infrastructure, which is probably one of the hardest to scale. And you want to defer the time you will have to scale it as long as you can, because it's going to be painful and cost a bit of money. So, and you can go a very long way without having to do anything really crazy with your databases. The second one is about image. Editorial websites are getting really image intensive this day, and the responsive thing that is coming from our friend in the front-end world is not making the thing easier for us in the back-end world. And now the same markup, HTML, need to work and render different content on a mobile, on a tablet, and on the desktop. And you probably don't want to show the same images on all these devices, and this makes things even harder. We will talk a bit about this. And the last point is about DevOps. And this one, it's not there has been talk about DevOps. It's something very important. I will just mention a few things, but it's something before going live, you need to have something that checks this box. This is something that you don't want to miss. So, a bit of buzzword and telling things that are fairly obvious is Django is web scale. That's not wow. It is, it's why we are using it. And in fact, it doesn't mean much. Yes, you can serve pages that are fairly fast with Django, and you can serve decent volume. That was a random day, and your page will get out in less than 150 milliseconds. It will be served to your users, and people will be happy. You have this is kind of volume. 2,000 requests per minute is decent load. So Django will take you there without, it won't be in your way, and other thing will not be Django related at all. Like, you would use anything else, you would have exactly the same problem. But this is a bit of a lie, in fact, because I'm saying Django is web scale, but Django is not really does not have any relation with scaling, in fact, because you will see that the thing which is important with the stack is that the framework don't get in your way, and Jacob did a great way to show you how you can remove pieces of Django if they are happening to be the bottleneck, but most of the case they will not be. And Django will just be fine, and what you are going to scale indeed is your cache strategy and your cache delivering system. So, like, this customer was fairly happy because the website was like #1 on Reddit for a day, and we are getting a decent load of traffic. And he was like asking me every 5 minutes, how's the server okay, and how things are going, like in the server room. And I don't know, like, we have no idea, let me check. And the server was just cruising really fine, because this is a very typical thing that don't help your service at all. Like, it's a page, a link that is posted somewhere, people click on the link, go on your site, and they will probably not even touch your Django servers. So everything will be served by Varnish or thing in front, and you will just see the bandwidth going up, and your database will not sweat, your Django application will not sweat, like everything will be just fine. So this is why it's a bit of a lie, saying that Django is web scale. Django doesn't get in your way when you want to scale it, which is the most important thing for a framework, actually. So now I'm going to talk about a multi-layer cache strategy, and there have been many talks about caching, and also during this conference. If you have to take only one thing away, is if you want a fast website, it's probably not by doing on every single request, checking fresh content, building the fresh content, manipulating your template, rendering everything, and pushing the fresh content. Because when you do this, we are talking about a few thousand requests per minute. So if every request I come there, ask for the home page, I need to retrieve the list of articles in the sport science and build the list of articles. I need to retrieve the images, and this is something you cannot do fast. You can only operate at that scale and return the request as fast as you can, because you don't want to lock your workers. This is really precious resources if your database. You want to return as fast as you can, and we'll see how you can do this. And actually, surprisingly, it's that simple. Yesterday I was talking with someone which is probably at the beach now. Don't see him. Thank you, Bruno. And he was just telling me, like, editorial websites are really easy to scale because things are easy to cache. And yes, they are. This is what I'm going to tell you. Like, it's not a problem. It's really easy. The first thing is, you probably want to avoid the request to touch your application as much as you can. So let me say a word about the stack that I'm going to describe, and this will be the hypothesis I'm going to make. We are going to talk about a load and balancer that can be Nginx, can be Rackspace load balancer, it can be any kind of load balancer that will distribute your traffic from the load balancer to Varnish, or several Varnish instances if you have some. And from Varnish, they will then touch your Django application. So this will be like your first shield to avoid the request to hit your application and then your database. So let's talk about this first step. Request getting and hit Varnish. What Varnish is going to do is actually super simple to describe. Also, Varnish is a bit like a Swiss Army knife that you can probably hurt yourself with. But with very minimal effort, you can make a huge impact on your website. I'm going to talk about only 3 tricks that can really save your life and the life of your website. And a side effect of this is Varnish will probably serve a page from 10 to 1,000 times faster than your Django stack would do. nothing magical. It's because Varnish is cheating, he's not doing anywhere. He's just taking an object from the cache and rendering everything and sending back to the user that requested the page. It's not doing anything fancy, it's really easy. The last line is a bit of a disclaimer. As a consulting company, we are meeting customer and we encounter some people that try to reinvent this wheel, and this wheel is hard, and you can hurt yourself. Just install this thing. Installing it is just a package, and then there is a configuration file. It's really simple, and you will have huge effect. So it's probably something you don't want to spend 3-4 months to work on, just to reinvent it. So the tree thing we are going to talk about, and I'm going to hurry a bit. If I'm going too fast, slow me down. It is about stripping the cookies, and we will see what that means. The stamp mode, and making sure that Varnish is returning a proper error page. Stripping the cookies is probably like the first thing that people usually install Varnish in front of their Django application and say it's not good, like I'm using it, it's installed and I'm hitting Varnish, and Varnish every time is telling that it's a hit miss and it's going to my Django database, and then the pony is sad. So in order to make the pony happy, what you need to do is first look at what your request vary on. So this is an header that is set, and it tells, like Django is telling Varnish what this request will vary on. And the default settings are accept languages, which makes sense. You don't want to send a German page to someone which is speaking French, or vice versa. It's something you would like to avoid, and make sure the German get a German page and the French page for Swiss. It's tricky. A cookie is something that seems really easy, but it appears in practice on most websites. Like, many people are putting cookie everywhere. Like the request, there is a ton of things that move with the request back and forth, and it's useless. So if you are using Google Analytics, they put their cookie. Chartbeat put its cookie. Like, everything put its cookie. And what you really need to do on the way in is make sure that your cookie gets stripped off. Like, you want to make sure that Django only gets requests and cookies that is useful for you. Like, there is absolutely no need to transfer cookie for Chartbeat. No need to transfer cookie for Google Analytics. Django applications don't need it, so remove them. And what the result with this, so on the way in, you would remove cookie, you remove all the cookies that don't have the session ID or CSRF token, because this is important pieces for Django. And you want to keep them. If a user is logged in, you probably don't want to show what this guy sees to all the people. And same thing for the CSRF token. This is important. Django application is using it. So by default, this would be the same thing to do. And then, so that's it when the request gets in, and when the request gets out, that means you get back from your Django app to Varnish. What you want to make sure is, if there is one of these cookies, to send the request really to your app, and if there is nothing, you can tell Varnish, okay, you can sell something from cache. So that means my guy at the beginning that click on the link from Reddit probably don't have any cache, because it's the web first site that is going to visit my website. And this guy will for sure get something from Varnish, and he will not touch my Django application. And this is really critical. It's absolutely critical. You want to preserve your Django application as much as possible, and this kind of very simple thing can take you a long way. By a long way, I mean, you would probably cut without much effort. Like, if you go with the very simple rules, you will probably cut your traffic by 50 to 80%. So that means in the data center where you used to have 8 boxes, you probably are all good with 4. less boxes, less problem, isn't it? The second one is also kind of a flip you want to switch on. It's something which is very surprising, and the first time you discover it's like mind-blowing. Let's say you have Varnish and now your Django application. And for some reason your Django application is dead, like it's dying. You broke it, or you deploy something, or the database is not healthy, or something happened, and this Django application is not able to answer any request. So the request will get in, reach Varnish, and in that case, what Varnish will do, if this switch is on, it will just serve stale content for the amount of time you decided. That means it's as simple as this. Your home page is probably stale, it's in the cache, has been hit by thousands of users before. User gets in, the backend is unhealthy, unable to answer. It will get a stale version of the home page, which is from a minute ago, an hour ago, 2 hours ago, 6 hours ago. Backend is still not there, so continue to serve it. And the user gets a real page, it's not getting an error page. Your website is down, but the user don't notice it. Of course, if you try to access a page that is not in the cache, it will get an error page. But this will cover your back for homepage, all the top section, most popular article. Like, okay, if someone is looking for an article come from Google on a 2 years old article that is getting 0 traffic page view a day and maybe 1 a day, and that's a guy, this guy will get an error. But you're getting still 2,000, 4,000 requests a minute. You don't want these 4,000 people to get back and start tweeting about your website being down. If a random person gets all the article an error page, it's you can live with it. So this is what we are going to describe. It's very, very easy. Few lines of code. The only interesting thing is the probe directive, is when you are probing your backend. So what Varnish is doing is accessing the URL slash, and in that case, every second it will access this URL, check if it's getting back before the timeout, which is 1 second, and say, okay, this guy is alive, it's healthy. If it's not the case, this guy is not alive, and we will go back to plan B. And in the case it's healthy, we will set the grace for an hour. In the case it's not healthy, we will set the grace for 6 hours. That means we will keep stale content for 6 hours. And this is content that we can keep serving. Like while you are fixing your problem. Your database, there is a deadlock, there is like someone left an IPDB statement in the most important precious middleware. I don't know, like plenty of reason to break your application, and this will cover your back while you get notified and fix it, because you will still get the notification that your backend is down, because this will raise an error, and if you are using any kind of monitoring software that you should, you will get notified. This is the place where the request gets back from the backend, you get a 500 family error, and you say, okay, the backend is probably feeling bad for a moment, so maybe we'll just switch to the send mode and try to serve from stale cache and keep probing it, and when you get back, we will switch it on LC after 30 seconds. Very easy, very simple. It's a few lines of code, and it's giving you a huge benefit. The last one I want to cover is like the default error page from Varnish is a white page talking about a meditation guru with a very huge random error. You probably have seen it on the internet. And when you user get it, it just gets like and yeah, not good. So you want to make sure that you are able, in case of a problem, to serve a proper design HTML page telling, we have a problem, guy, can you do something? Caching strategy, like we are going one down, like we already dropped the number of requests by 80%. Let's go down the stack. Not fast enough yet. So when you start talking about caching strategy, you will probably have seen this code just in this conference 3 times, but it's like most thin code, and the problem is like nobody knows exactly who saved it, so like you will find version of it, but it's now on every slide, so you know it. And in fact, the bad side effect of this code is when you start talking about caching, people tell you, no, I don't want to lose my job. Like, this is the most difficult thing, I don't want to do it. And in fact, as the guy at the beach told me yesterday, it is not. Like, it is very simple to do it on a content stack. It's that simple. I'm going to show you why. This is a strategy we are going to review. The first one is a Richard-Doll caching. Like, the idea is to have a nested cache. So, you know, Richard-Doll is a doll in a doll in a doll, and as you go, it gets smaller. In that case, it would be a cache HTML fragment, a cache HTML fragment, a cache HTML fragment, and as you go down, the TTL will get longer. So this is a typical article list that is cached for a middle TTL, which might be 10 minutes. And as you go down, for an article, you say, my article has a long TTL, let's say a day. I want to cache it for a day, but it might be 25 days. And as a key, you are using the article ID and the last modified date of your article. So, if the last modified date is still the same, there is a good chance that this article hasn't changed, right? So, and validation, you get it for free. You don't need to do anything. Like, if the article date has changed, or you save this article again, it's just getting validated automatically. Nothing else. And one of the great properties of this pattern is it gets faster as you get more traffic. That sounds great, right? Because you do less cache get and set, so it gets faster. And at the end, you only get like the big doll, like the one outside that just send back the HTML down. And you see the drop off, and this is probably like this line is when some of the cache get invalidated. The thing is, you see it's not really it's not a cliff, it's a gentle bump. And gentle bump is coming from the pattern we are going to see right now. It's a cache ETL, as you have noticed, I'm not putting an integer. Also, this is expecting an integer. I'm putting a variable, and this variable is defining my setting. We'll talk about this later. But what we are doing is, you might want to fork the default cache fragment and say, I'm going to cache for a TTL, but the TTL is not really the TTL. It's only one TTL. It will be this TTL plus minus 20%. So if you do on a page for a given TTL, if you do a cache, if you cache 100 fragments, you are pretty sure that it's not a single guy that will come and pay the price of resetting the cache for this 100 cache set. It will be distributed on all the people cruising on your side, and you still have, I told you, several thousand of people per minute, so some of them will get slightly slower, but it's okay. You can live with it. Central definition, don't go and start adding, so this is 600, 550, no. Go put this in your settings file. And then when you start to optimize your website and look into your, whatever you are using to monitor the speed of your website, it might be Neuralink, might be the graph I'm using off from Neuralink, might be something else. But you will have like very simple places where you can tweak it. So this is 600. What's happened if I put 500? What's happened if I put 400? And it's very easy and simple access, and you can just do a redeploy to change it. No harm. But the side effect of this strategy is we start to put a lot of things in the cache, and the cache is becoming like a critical piece of our infrastructure. What happens if one of the servers is dying? Like my cache to make absolutely sure that you will continue to sell the website. Yes, it will be slow, much slower. Yes, your database will work much harder, but you don't want to return a 500 because one of the nodes of your memcached cluster is going away. And this is probably what you are, if you are using the default cache backend, what you are doing. You want to make sure that the cache backend you are using is catching every exception, logging them to the place where they should be logged, so you are notified, hey guys, the cache cluster is down, you should rather do something very fast. As Varnish will start going into this send mode where, because the requests are too slow, so it will send stale content, which will give you some time to fix things. But this is an example of a cluster, not cluster going down. The last one is about cache buster URL. You want to have a URL that is easy and where you are sure that if you read this secret URL that nobody knows, you will burst everything and get fresh content. Like this, you can give this to the editor-in-chief, and if he's not okay with a 1 million TTL, or if he has something that needs to be fixed now, but like yesterday now, he can use this one. Last thing you want to cache is database query. There is a Jolly Cache is a drop-in replacement. It's a drop-in middleware. You can put it there. It will just avoid a ton of query on your database. Your database will cruise idle most of the case. And this one is fantastic because it is very simple to install and it's very unlikely that you will serve anything stale. Like he is very aggressive in invalidating things. It's invalidating way too much, but it's really safe assumption. The last thing is don't use a database session, use something else. So now about the image management on responsive website. I told you one of the problems is we are getting way more images. You will from now understand why. This is a desktop, it's the same markup. And this is a desktop version of a website, and this is just a mobile version. And in between there is a tablet version, which is slightly different too, and the size of the images is different. What is surprising there is the thumbnail, for instance, on the mobile version is bigger than on the desktop version, which might be counterintuitive, but it's because you can click on it. But this is not the point. What is interesting is, just by doing this responsive thing, because it's what people want now, you just have 3 times more images on your page. And it's like slight detail. If you had 1 million images, you now have 3 million images to take care of. And again, this is where, in the Django ecosystem, there is plenty of tools that give you a very nice feature set that customer like and want. The problem is, most of them operate under an assumption which is not true when you are talking about cloud container. And the cloud container are, in fact, slow and unreliable disks, which is the opposite assumption done by those things. And so you probably will end up forking this thing and fixing things that don't match with your system. And this is where it's getting on. On this project, we forked Filer, we forked Easy Thumbnail. Also Easy Thumbnail, we are close to get back to the upstream because like, the guy working on it is from our group, so it makes things easier. Cumulus, just this one has 81 fork, and it's like everyone is jumping on it and doing what they need. And Pyrax is something down the stack that you also want to monkey patch because probably the default settings are not the one you want. So if you have to take only one thing away from using this kind of stack, is you want to be very, very sure that when you are developing, you have in that case, Swift client, because I'm making the assumption that we are working with Rackspace, but you want to make sure that every time there is an API call, because of your images, you know about them. And you want to tend to the goal that you have 0 call on a page. It's not acceptable to do 1 call per images if you have 60 images on the page. That will make changes that you might want to do on Cumulus. It's detail oriented and we don't have time. But the assumption you should, this API is very polite, like can we do this, is this existing, if it doesn't exist, let me try to retry to see if it really doesn't exist because maybe it's an API that was just failing and it's really there. You want to just be fast, so we'll just, if I say, but just override what is there. If it says it doesn't exist, next time maybe it will tell me something different, but that will be another story. And this is something annoying, is like the stack in here is really, really deep. Like you are pulling probably 15 dependencies. And when you instantiate a storage backend, you cannot override all the components in the stack. So what you end up doing most of the time is having this patching function that starts monkey patching things, like when you import them for the first time to make sure they have the right settings. The next thing is when your editors get these images, what you want to make sure to do is, as soon as they upload the images, go and process them and create like the 16 different sizes of the thumbnail, because thumbnailing is becoming expensive. Instead of having 6 sizes, you now have probably 3 times more, if it's not 4 or 5 times more. So you're going to have a queue that will just say, okay, every time we save a model with an image field, we want to create all these thumbnails and go do it. And it will do it. So now your thumbnail has been created. You are not doing any API call when you are displaying something. The next step is you want, with the same markup, to be able to display the right images based on the viewport, based on the size or the width of the device you are using. So this is the library you want to use if you need to support a large set of browsers. It has a special markup that lets you define. So you set the medium for this side, the large for this side, the extra large for this one. If we are putting it all together, this is the first example of reasonable caching that we were talking about. And my images are in the article teaser. And notice that we are caching outside the include instead of inside the include. And this will look like this. So I will probably do this every 25 days. Like it has the longest expiration TTL, so everything will be cached. I will not touch any thumbnail. It will be done once and then forgotten about. The last thing I want to read is the DevOps part. And I'm going to go very fast because I want to keep time for questions. Configuration management, there is many. I hope that by now you are, and by the people that gave great talk about them before, you are convinced that you need to choose one. And really, just go with the one that fits your brain and your skill set. They are all good, they are different, make different assumptions. Pick one. If you ask which one we choose salt, but I would say doesn't really matter. This is the kind of thing you will be able to do with this tool. Is someone come tell you that there will be a huge marketing campaign and the traffic is probably going to be multiplied by 10. You probably want to provision some boxes and push a configuration to give them the role. You want to be done with this and be sure that those boxes have the same configuration. You can also run not random, but you can run command on these boxes, make selection, and it's very powerful tool. The last point is setting parity. We had the lightning talk about 12 factors, and this is something you should really try to look into. And if you can have the same settings.py in your staging, pre-prod, and production, it's going to really help you. I know there is some slight differences, like database password, like key for an API, or this one you want to either use a .env file or use environment variable to populate your settings. But the settings file will be the same, and no differences in the way your site will operate. So I hope that by now you are convinced that going to that scale isn't that scary, and it's fairly easy to do as long as you go one step at a time and and don't be afraid of caching. Like caching, you will never have a fast website if you try just to have more hardware. Hardware will not give you a faster website in many cases, or not fast enough. And again, content sites are very easy to cache. And as people would go and line up for asking questions if they have, we started yesterday or the day before a campaign to create this book. That will be a high performance Django, where we are going to collect like the practice we have been using on this kind of websites. And there is a very short URL you can go to and pre-order the book.